So you've had a little bit of time to do A and B. Let's see how you did. So again, for number 3, we have an equation that looks very similar to the quadratics that you've seen in grade 10. So the first question is, what is the initial velocity of the rock? So when it's talking about velocity would be the first derivative, right? We have to get the first derivative, and then we'll worry about the initial part. So in order to get the velocity, we need to get the first derivative of the displacement function. So we could call that h prime of t. So that would be negative 4.9 and then times 2, right? So that would be negative 9.8 t. And then that would be an exponent of 1, so plus 12. And that's it. So this is h prime of t. This is also equal to, right, our velocity function, which we said we can write as v of t is our velocity function. So now just to write down for initial, that important word for the initial velocity, we want to set, initial would mean like at the beginning, right? So what is the movement? What is the speed at the very beginning? So at the very beginning, then my time would be 0. So all I'm going to do is set inside here in the bracket, t for time is 0. So v at 0, I have to use this velocity h prime of t function. So I have negative 9.8 times 0 plus 12. Obviously, anything times 0, then I just have an answer of 12. And for velocity, it would be, we're talking about meters and seconds, so meters per second. So also we can see here, it's a positive number. We know that this is a vertical motion. I'm just looking at where we are on page 1, the very bottom where it talks about vertical motion. So the first bullet there, when velocity is greater than 0, so ours is 12, we know that the object is moving upwards. So let's just write that down just to start kind of memorizing that. So it's a positive velocity, which means that the rock is being thrown upwards. Therefore, the rock is being, like at the current moment, thrown upwards. It's not on its way down yet. We haven't hit the maximum, the vertex yet. And you'd put a therefore statement. So therefore, the initial velocity of the rock is 12, and put your units meters per second. So also just there, put another therefore statement. Okay, so now the next question is when? When does the rock reach the maximum height? And what is that maximum height? So when would be your time along your x-axis? What is the maximum height would be again along your y-axis? It's basically asking for both numbers of the maximum height, which is your vertex, right? So at the vertex, I kind of explained that to you guys in the last video, but at the vertex, the tangent line is horizontal. Your tangent line is horizontal. So if your tangent line is horizontal, then you are not moving at that point, right? Then your velocity is 0. So if your velocity is 0, it's a 0, we're talking about your first derivative. So why don't we write that out again? My velocity function is negative 9.8 t plus 12. And if, now be careful here, this was time is 0. So I put 0 in for time. This is the entire velocity. My velocity is 0, so the left-hand side of the equation, right, is 0. And then I'm solving for t, which is answering my when. When does the rock reach the maximum height? At that maximum height, again, if we have a rock here, right, at this maximum height, my tangent line, trying to do it horizontally, is 0, right? So what is the time is what we're figuring out right now. What time is that? So if I were to move the negative 9.8 over to make it positive, 9.8 t equals 12. And then, divide by 9.8 to get t by itself. And I should have a value of t equal to, I can see it's going to be positive it's approximately 1.22, not exactly. So you could put a dot above your equal sign. And so that would be in seconds, right? So 1.22 s for seconds. So if I want the maximum height, right? In order to figure out the maximum height, then I need to sub it into a height formula, right? So that would be my original formula. So let's just write down here for height, I need to use h of t function. So let's write that out again. H of t is equal to negative 4.9 t squared plus 12t plus 15, because we want the height, and that's our height equation. So the height at a time of 1.22, because what we did was we found our time when the velocity is 0. So at that time, if we know that that's where the vertex is, that's fine to sub it into the equation, then that's going to give us our height, right? So negative 4.9, again, we're doing BEDMAS rules here, 1.22 squared first and then multiply. And 12 times 1.22 and plus 15. And you guys should be able to do all this basically in your sleep now. So I'm just going to skip ahead and I'll say it, I just won't write it all down. So 1.22 squared is 1.4884. Okay, so you have 1.4884 multiplied by negative 4.9. 12 times 1.22 is 14.64, and then you're going to add 15, and you should end up with an answer of 22.34684, and that's height, so that would be meters. And then you just put your therefore statement, right? So again, what does the question ask? When does the rock reach the maximum height, and what is the maximum height? So therefore, at a time of 1.22 seconds, the rock reaches a maximum height of 22 point, if it was 1 decimal place or 2, so 22.35, right? Or 22.3 meters high. Okay, so we haven't looked at C yet. What is the acceleration of the rock? So here we've practiced velocity, vertex, where the velocity is 0. We've reviewed that. Now acceleration now is the second derivative, right? Let me clear the screen though and move this up. What's the acceleration at 1 second and at 2 seconds? Because it could be accelerating or it could be decelerating. Is it going faster and faster and faster and speeding up, or hitting the gas in a car? Or is it slowing? I'm still moving, but I'm slowing down. So kind of like hitting the brake, but you're not stopped yet in the car. Okay, so let's move this up. So first off is to get my second derivative. So let's write that down, that's what we need to do. We know what the first derivative is, was h prime of t, or we called it, oh sure, let's just leave it as h prime of t then for now, which we also called v of t, right? Velocity was negative 9.8 t plus 12. And then I'm just going to get the derivative of that, my second derivative, h double prime of t, we called it, right? So this would be negative 9.8. And you know what? That's it. Negative 9.8. That's equal to, right, my acceleration. That's my acceleration function. That's my acceleration formula. So in order to find, well, first of all, that's a constant number, right? It's just a number by itself. It's a constant. So no matter what the time would be, acceleration is always this number. So for example, if I want the acceleration at 1 second, so just to write that down, at 1 second, I've got my acceleration at a time of 1. Well, if this is my formula, I don't have any t's to plug in the 1. I just have this. Now, what would my units be? We're talking about meters and seconds, but when it's acceleration, it would be meters per second squared, okay? Meters per second squared. So then at 2 seconds, we still need to write them down, right? The acceleration at 2 seconds, again, my formula is negative 9.8. That's all I've got. I don't have a t to sub in t of 2. So negative 9.8 meters per second squared. So all this is telling me is, again, it doesn't mean I'm not moving, right? I have a velocity, the number is here. It's just a constant number. So this is like if I'm in cruise control in the car. I'm moving at a constant speed, that's all that's saying. So to know if I'm accelerating or decelerating, I have to look at the velocity as well, right? To know if I'm accelerating or decelerating, I have to look at the velocity too. So let's look at the velocity at 1 second. So first, maybe we should write down our velocity formula. Well, it's right here, I guess. That way we don't have to write it down again. It's negative 9.8 t plus 12. So that's what we're looking at now. So our velocity at 1 is negative 9.8, right, times 1 plus 12. So basically negative 9.8 plus 12 is 2.2. And again, that's meters per second now. Second squared is acceleration, per second is velocity, right? If your velocity, remember, is a positive number, this is a rock, so we're talking about vertical movement, then that means that it's going up, it's on its way up. That's all we know so far with this positive number. Let me just plug in 2 and then we'll talk about how we can tell if it's accelerating or decelerating, right? So we have the velocity at 2 is, again, my velocity formula, don't forget, negative 9.8 times 2 plus 12. So again, I think you guys should be able to multiply that and add 12 and we can just go right to the answer. I have negative 7.6, so it's negative meters per second. So again, because it's negative, I know it's on its way down. I know the direction of the movement, but that's not telling me whether it's accelerating or decelerating, right? In order to know if it's accelerating or decelerating, I need to look at the sign of the velocity and the sign of the acceleration. So just to go back here, again, I'm going to leave this up, but just to go back to show you where are we? Acceleration, this chart here. An object speeds up, so is accelerating when the velocity and the acceleration have the same signs. And if they're opposite signs, then it's slowing down. So that's what we're looking at here. So let's go back here to C. So my velocity at 1 second is positive number. My acceleration at 1 second is a negative number. So do you remember what that chart just said? I have a positive number and a negative number. So just to point out here, let's change our color. Oh, we have the signs are different. The signs are different. So that means that it's slowing down, right? So the rock is, therefore, the rock is decelerating. So kind of like pushing on the brakes. If it's well, we'll talk about that after. Let's talk about the next one and then I'll go back and talk about that. So my velocity at 2 is negative, right? And my acceleration at 2 is negative. So here we have the same sign. So therefore the rock is accelerating. Right? And we also know what the vertex is. If you look up in B at your notes, right, we know that the vertex was happening at 1.22 seconds. So again, if we were to draw this out, the vertex is at 1.22 seconds, right? So at 1 second, right, just to the left of it, it's still going up. That makes sense. It's still going up. But as it's fighting against gravity, right, and going higher in the air, the rock is slowing down, which is what we said here. The rock is decelerating. It makes sense too, comparing it to the graph. And then we also know at 2 seconds, right, would be to the right of the vertex. So again, just a random spot. If this was at 2 seconds here, we know that it's on its way down, but also this velocity function here being negative is telling us that it's on its way down. It's proving that to us. And also if it's on its way down, it's going with gravity. It's going to be speeding up, speeding up, speeding up as it goes, right? So again, the rock is now accelerating. So that makes sense. So let's look at D. When does the rock hit the water? And at what velocity does this occur? So basically, this could have been a grade 10 question, right? When does the rock hit the water? The new part is, what is basically the speed of the rock? What's the velocity of the rock when this occurs? So again, velocity and speed are very similar. It's just that velocity also gives us the direction, right? If it's positive or negative, whereas speed cannot be. We'll talk about that when we answer this question, but speed cannot be positive or negative, right? So it also gives us the movement, the direction of the movement, velocity. But basically, we're talking about the same thing. So when does the rock hit the water? When the rock, again here, let's say hits the water, it's going to have a height of 0. So let's just write that down. Let's change our colors so we know we're on a different question. So therefore, the height equals 0. So if the height equals 0, again, I need my height formula. That's going to be my original formula. So if I want to, because it's way up there at the top, if I want to just rewrite that, negative 4.9 t squared plus 12t plus 15. And if the height is 0, then that means h of t, the entire thing, is equal to 0. So the whole left-hand side is equal to 0. Then we look at here, if this is a grade 10 question, right? How would I have solved this in grade 10? Can I factor this? Hopefully you remember that if you ever had decimals, it wouldn't be very easy to factor. And do you remember what we did? Quadratic formula. Do you guys remember what that formula is? So let's write it out here. Instead of x's, we have t's. So we'll say t equals, remember, negative b plus or minus b squared minus 4ac all over 2a. And make sure you've got your signs. Negative b, negative, plus minus. This is positive, b squared. There's a minus there, negative 4ac all over 2a. And let's just write down, it's in standard form. We have our a value is, be careful that it's negative 4.9. Our b value is positive 12, and our c value is positive 15. And so again, I don't know if I want to plug this in with you. I feel like you guys should be able to do it. But 12 squared minus 4 times a times c all over 2a. 2 times negative 4.9, I already know is negative 9.8. So I'm just going to go ahead and write that in right away. So if you do the math, 12 squared is 144, right? You've got a negative times a negative, which is a positive, and then that resulting positive times a positive. So you're going to have 144 plus whatever these three things are multiplied together. So you end up with, underneath the square root, you end up with 438. And I'm going to leave you guys to do the work. Pause the video if you're at home, or we'll pause it in class. And then do you remember what to do from here? I'm going to go to the left just because I know there's more to the question, right? What's the speed? What's the velocity? So we're going to need that space over here. So sorry to be a bit messy, but I'm going to move it over here. So then I have time, right? Equaling the negative 12. And then let's do the plus side first. Plus the square root of 438 over negative 9.8. And that time I get negative 0.91. Hopefully you have as well. So that, again, time, that'd be seconds. And my other time would be negative 12 subtract the square root of 438 all over negative 9.8. And that time I have 3.36. So obviously for time, we're looking at the two values here. I can't have a negative time, right? So that one doesn't make sense. So in my therefore statement, when does the rock hit the water? Therefore, the rock hits the water at 3.36 seconds. But we need to find the velocity. At what velocity does this occur? Kind of what speed is the rock going at when it hits the water? How fast is it going? And it's also going to tell us the direction of it, right? So for velocity, any idea what to do here? Do we have our velocity function? That's our first derivative, right? Velocity, let's just write that down then. Our velocity function is negative 9.8 t plus 12. Do we have any information? We have 3.36 seconds. So we're just going to sub in 3.36 seconds. So negative 9.8, sorry for the announcement, plus 12. So again, multiply this first, you're going to get a negative number. And then when you add 12, you should have an answer of negative 20. I have 0.928, I believe, if I can read my writing. 928 in velocity, meters per second, right? We put the units here for seconds. Now velocity is meters per second. Now I do have a negative. So the negative means the movement, the direction. So the negative means that it's on its way down. So again, I'm just going to write this down just for like studying purposes for you guys to start to understand this. So the negative means it's on its way down. It means it's on the right hand side of the quadratic, right? So it's on its way down. But if I was talking about speed, then I wouldn't use a negative sign, right? So it doesn't ask for the speed, it asks for the velocity, but obviously for speed, it's just always the positive number. I wouldn't include the negative. So here it's asking for the velocity. So for my therefore statement, therefore the rock's velocity when it hits the water is approximately negative 20, and let's say we do 2 decimal places, 0.93 meters per second. So we have the speed, but we also have the direction of the movement there too with the velocity. Okay, I know this is a long one, this note. So let's do number 4. And then I'll have you guys look ahead at 5 again, maybe give you a break there, and then we'll take up 5 in another video. So 4, we're talking, so far 3 was an example of vertical movement, right? So again, if we go back to, I'm just gonna go back to the same page, so I'm looking at the same thing as you, page 1. We just did vertical motion. If we read number 4, a particle moves along a line. So now we're talking about, so I'm doing an example of horizontal motion with you. The particle's position, S of t function, which is in centimeters now, and t is in seconds. We have the equation S of t equals t cubed minus 9t squared plus 24t plus 20. Obviously, t being time has to be greater than or equal to 0, can't be negative. So there's our displacement function there, right? So if you want to write down, this is a horizontal motion question, to refer back to the bullets on page 1. And we will refer back to that horizontal motion question. Determine the average velocity of the particle between 2 seconds and 4 seconds. So starting at 2 seconds and ending at 4 seconds, what's the average speed? But again, velocity is giving us the direction also that it's going in. So let's just talk about what the average velocity formula is before we figure out what to do here. So velocity is talking about speed and time, right? So we're talking about the difference of the displacement, which is where it is in time, the difference of displacement, where it is, divided by the difference in time. So if you look, my displacement function though, right, is this original equation. My difference in time, I have the time here, 2 seconds and 4 seconds. So the interesting thing is, if you just think this through first, I actually don't need to get the first derivative here. I'm actually not using the, like a velocity formula. I'm using the original formula because it is my displacement function. So what I'm looking at is the difference in S over the difference in T, right? The change of S over the change in T, which is S at, remember, usually you pick the larger number first, right? So the displacement function at 4 seconds, change difference means subtracted by the displacement function at 2 seconds, again, divided by the difference in time. Well, the time was 4 seconds and 2 seconds. Now, displacement, where I am along the line, would be in centimeters, right? Just to kind of show here, there's my centimeters. My time is in seconds, so my answer will be in centimeters per second, right? Which also velocity is too, right? Velocity is centimeters per second. So I know that can be a little bit confusing, but in order to get the average velocity, we are getting an answer of centimeters per second, but we're talking about the original displacement formula. So now let's figure out if I plugged in S at a value of 4 for time. So S at a value of 4, right, is just plugging it in to the original. 4 cubed minus 9 times 4 squared plus 24 times 4 plus 20. So again, I think you guys can do the math, cube that, square that, then multiply it by -9, multiply that, add them all together. And I have 36. Right, so we plugged in at a time of 4. So my answer would be, where am I horizontally along the line? I'm at 34. Our units are centimeters, right? So same at a time of 2 in my displacement function, I would have 2 cubed minus 9 times 2 squared plus 24 times 2 plus 20. And again, I think you guys can do the math. I have an answer of 40 centimeters. So then going back to our formula here, S at 4 at a time of 4 is 36 minus 40 over 4 take away 2 is -4 over 2, which is -2, remember, centimeters per second. So I have the speed, like 2 centimeters per second, but I also have the negative, the movement, right? So just so you can look, if you go to your first page again, and we're talking about horizontal motion, if our velocity is less than 0, then the object is moving to the left or retreating, right? But for this particular question, we have the average velocity between 2 and 4 seconds right there. So just answer with your therefore statement. Therefore, the average velocity between 2 and 4 seconds is -2 centimeters per second. And just add that into your therefore statement. Determine the initial position of the particle. Where exactly is the particle? Again, initially would be at a time of 0, right? So if time is 0, I'm just using my original displacement function and I'm just plugging 0 in for time. So 0 cubed minus 9 times 0 squared plus 24 times 0. And whenever 0 is there, it just kind of wipes everything out, right? And I get an answer of 20 centimeters. So again, your therefore statement. Therefore, the initial position of the particle is 20 centimeters. When is the particle stationary? So what does stationary mean? So for the particle to be stationary, that means it's not moving, literally not moving. It's not in cruise control or anything. It's literally not moving. When it's not moving, then my velocity function is 0. So in this case, I do need to get my first derivative to get my velocity function now, right? I need my first derivative. So let's figure out S prime of t. So 3t squared negative 18t plus 24, which is the same thing as my velocity function, right? S prime of t and v of t are the same thing. 3t squared minus 18t plus 24. So now it's saying, when is it stationary? My velocity is 0. Again, so that would be the whole left-hand side of the equation is 0. And usually when we have an equation like this and we need to solve for t, it's factoring, right? So we need to factor here. Now, there is no decimal. I mean, you can use quadratic formula for everything we learned, right? It just takes a bit of time. So is there a faster way? Can I do this without using the quadratic formula? There's no common t. Obviously, you always check for GCF first, but does 3 work with 18? Does 3 work with 24? And it actually does. So if I take a common factor out of 3, I'm left with t squared minus what? 6, 12, 18, 8, 16, 24. So t squared minus 6t plus 8. And now I'm looking at a simple trinomial to factor. So what two numbers multiply to 8 and add to negative 6? So again, 1 times 8, 2 times 4. Which one is going to give me the negative 6? The negative 2 and the negative 4. So then I'm ending up with a 3, t minus 2, and t minus 4, obviously equaling 0. And then I can figure out what my value is for t, right? So if I were to set, again, t minus 2 equals 0, t minus 4 equals 0, or you just know it's the opposite of what is in the brackets. So therefore I have, sorry, I should fit it underneath here, but I just don't have room. So one value is t, time would be 2, and another value would be time would be 4, where the velocity is 0. Do both of these times make sense? They actually do. So for my therefore statement, therefore the particle is stationary. Therefore the particle is stationary at 2 seconds and at 4 seconds, just in 2 different spots. And we'll actually take a look at graphically what this looks like for the next question for D. So at 2 seconds, it's not moving, and at 4 seconds, it's not moving. So we kind of, just to think ahead here, when it's not moving, where would you be along the line, along the curve? Right, just exactly at that point in time, right? Then again, your tangent lines would be horizontal. Your slopes would be 0. So let's head into D here. Hope I can fit all this in. When is the particle advancing or retreating? So if we're talking about advancing or retreating, we're talking about kind of what I was saying there in C, right? Taking a look at where I am along the line. So if I'm looking at what, my velocity function, or if I'm advancing or retreating, I need to look at my acceleration, right? So if we looked at, there's 2 different ways we can kind of look at this here. Just debating here if I want to show you the graph first or look at it a different way first. Let's refer back to C. So if we know that the particle is stopped at 2 seconds and at 4 seconds, so I'm just going to draw this out like this here. So at 2 seconds and at 4 seconds, the particle is stopped, right? Unless obviously we have 0, time cannot be less than 0. If I were to pick a value between 0 and 2, then I want to take a look at, am I advancing or retreating, basically, right? So if it's positive, if I plug in a value, I mean, 1 would probably be the easiest one to plug in, right? If I plug in a value of 1, am I advancing or retreating? And then same, but because I know that at 2, I'm not moving, and I know that at 4, I'm not moving. And then if I pick a random number, which obviously 3 would make the most sense, between 2 and 4, all I care about is that number positive or negative. So again, if it's positive, it's going to tell me I'm advancing, and if it's negative, it's going to tell me I'm retreating. And then I'll also draw a graph out for you, which would be similar to grade 12 functions, if you remember that. So if we plug in, let's say, a value of 1 and plug it into our velocity function, right? Because if you go back to your velocity, page 1 here for horizontal movement, right? If velocity is greater than 0, then the object is moving to the right. If velocity is less than 0, then the object is moving to the left. And that's advancing or retreating. So sorry, it's not talking about speed here for that question. We're talking about velocity. Advancing and retreating, we're talking about velocity. So let's plug in a value of 1. Plug in 1, and here plug in, and again, you could have plugged in any number you want. Plug in 1 and plug in 3 into the velocity function. Okay, so my velocity function, if we want to write it down again, was from C, we have it down right up above, I just can't see it. So 3t squared minus 18t plus 24. Plug in 1 squared minus 18 plus 24, right? Negative 18 times 1. And so we have an answer of, what do you guys have? 9 centimeters per second, right? To include your units. Okay. So that's a velocity of 1, I should say. And then let's plug in first, before we analyze this, the velocity of 3. So again, 3 times 3 squared minus 18 times 3 plus 24. We want to do 9, 18, 27. 18 times 3 plus 24. And what do you have a final answer of? So I have minus 54 plus 24. So I end up with a final answer of negative 3 centimeters per second for that. So like we said, at a velocity of 1, at a time of 1, my velocity is positive. So if it's positive, just right here, if it's positive, then it's advancing. So that means in here, I'm advancing between 0 and 2. And at 2, I am not moving, right? Between 2 and 4, at a value of 3, I'm negative. And if I'm negative, it means I'm retreating, or kind of like moving to the left horizontally along the line, right? So here I'm retreating in between. And again, at 2 and at 4, I'm not moving. So let's compare this to your graph and then figure out how we want to write this out. So if I was to graph this, we've got a time of 4. I'm just randomly just doing a sketch, right? Time. A time of 2 and a time of 4. And we know that at a time of 0, if we go up to B, the initial position, at a time of 0, I was at 20 centimeters. So at 0, I was at, just randomly, I'm going to say that's at 20 centimeters. And then if I'm not moving at 2 and I'm not moving at 4, then those are like maximum and minimum values, right? Where your tangent line is 0, where your slope is 0. But if this is telling me that I'm advancing, advancing means moving up. So I'm going up till I get to 2, then I'm not moving. And then if between 2 and 4 I'm retreating because I'm at a value of 3, I was negative, then I'm going back down, right? Again, at some point here, and then if that's the lowest point, then I'm coming back up. So my line, my curve looks something like this to compare it to. So here I'm advancing. Here I'm retreating between these maximum and minimum points. And again, beyond 4, I should be advancing again. And if we wanted to even just test that out at a velocity of 5, right, just picking a value after 4. So at a velocity of 5, plugging that in, I'd have 3 times 5 squared minus 18 times 5 plus 24. you have 75 minus, here I'll write it down, 75 minus 90 plus 24. So I end up with a value back at 9 centimeters per second. But again, all I really care about is that it's a positive number. So because it's positive, it's proving again that it's advancing. So that makes sense. So when is the particle advancing and when is the particle retreating? So for my therefore statement here, therefore including 0, but less than 2, right? Because at 2, it's not advancing. At 2, it's not moving at all. So between 0 and 2 and including 0, but also after 4, when t is greater than 4, the particle is advancing. But between 2 and 4, right? Not including 2 and not including 4. So just 2 not equal to brackets. Just t is greater than 4 and t, sorry, did I say 4? T is greater than 2 and t is less than 4. Then the particle is retreating, right? Between 2 and 4. I know I don't have room here. It is retreating. So just to go, sorry, I know this is sloppy here. Therefore, between 0 and 2, including 0, and when it's greater than 4, the particle is advancing. And between 2 and 4, not including those numbers, it is retreating. And that's how our graph is showing that to us as well. So for E, what is the total distance traveled by the particle? But we're only talking about in the first 5 seconds, right? We have to put an end to this somewhere. So between 0 and 5 seconds, we're talking about, right? So between 0 and 5 seconds, including 0 and including 5, what's the total distance traveled? So distance it's talking about, we were talking about before, if I'm starting in London, driving to Toronto, then driving to Woodstock and making a stop in Woodstock, and then eventually heading back to London, right? Distance doesn't care whether I was driving to Toronto or from Toronto back to London. So if it's 150 kilometers from London to Toronto and 150 kilometers back, just to say, the distance would be 300 kilometers. I wouldn't include that going to Toronto is positive 150 and coming back is negative 150, right? Like with velocity, because it's just talking about distance. So just keep that in mind when we're answering the question, that we're not caring about the sign in this case, right? But we'll discuss that. So we don't have a distance equation here. Our original equation is a displacement equation. So we have to use that to find out what the distance is. Now our displacement again is how far away I am from an object. And that is going to have positive and negative values. So to figure out the total distance, let's take it in intervals, like we comparing it to D. So the total distance, we know that we have key values here at 0, at 2, at 0, at 2, it's not moving. So we want the displacement function at 2, subtracting the displacement function at 0. So we're looking at between 0 and 2, what was our distance? And then we're going to add to that between 2 and 4, what's our distance? So S at 4 minus S at 2. And then we're going to add to that. So this is 1 section. This is 2 sections. And then we're stopping at 5. So between 5 and 4. S at 5 minus S at 4. That's our third section. So obviously we're stopping again. I'm just guessing here at 5. Would probably still be on our way up. And just plug in those values. Now, a lot of them we have. So if we go back up, I'm just looking here where some of them I have written down in A, the value of S at 4, S at 2. We have S at 0 in B. So let's just maybe go in order in terms of like starting at 0. So S at 0, our answer from B, again, getting our answer there is, I'm just double checking it, 20 centimeters. Then S at 2, which I have that number from A, is 40. And then S at 4, again from A, is 36. And then S at 5, which is nice, we just did that randomly for D. We didn't have to. I have 9, right? S at 5. Oh, sorry. Good thing I caught that. That was velocity at 5. We have to plug into the original displacement function at 5, sorry. So we would have 5 cubed, just to go over this, minus 9 times 5 squared, plus 24 times 5, plus 20. So 5 times 5 times 5, 5 squared, 25, 25 times negative 9. So if I plug that into the original, hopefully you end up with an answer of 40. So I'm back at 40 again. So I have here, let's plug in S at 2, just be careful you have the right numbers. 40 subtract S at 0 is 20, plus S at 4, 36, minus 40, plus 40, S at 5, minus S at 4, 36. And I just wanted to kind of say here, 40 minus 20 is 20, right? But 36 minus 40, I would have a negative 4. So negative 4, obviously, to me, just means I'm moving in a different direction, right? Again, maybe that would be 20 is driving from London to Toronto, and the negative 4 just means I've turned around and I'm coming back, right? But if I'm talking about distance, I don't care if it's positive or negative. So I need to indicate somewhere here that I'm only using the positive values of these, that there is no negative distance, right? So what I'm actually going to do is, from grade 11, I'm going to take the absolute value of these intervals. So the absolute value of 36 minus 40, I'd have negative 4, but the absolute value, I can do that as another step, of negative 4 would just be 4, right? Plus the absolute value of 4, and obviously I guess it would be the absolute value of 20. So I'd have 20 plus, this one would change to positive 4. So I would have a total distance of 28 centimeters, right? Because we're talking about that the line, horizontal line, is in centimeters. So again, the negative just means that I'm kind of backtracking, driving back from Toronto to London, but it's not asking about my velocity. It's asking about the actual distance this time. So it just wants a positive answer. So when it's asking for distance, you can just take the absolute value of those intervals of time. So again, therefore statement, therefore the total distance traveled by the particle in the first 5 seconds was 28 centimeters. Okay, we have a totally different question for 5. Again, I'm just going to have you guys look at it ahead of me here, and then we can take that up. Last part of this video. So the graph shows the position of a bicycle. State whether the velocity and acceleration are positive, negative, or 0 for each interval. So between A and B, between B and C, that's a third section, 4th, 5th, and 6th. So here we have the different intervals here. They also have us look at exactly at D, right? Where I'm just going to say where I'm not moving there, right? Also indicate whether the bicycle is speeding up or slowing down. So if I'm speeding up or slowing down, we're talking about acceleration. If it's positive, negative, or 0, I'm talking about the velocity. So again, oh, I thought this was all one question. I guess there still is part 6 here, but that won't take too long to do. So I'll give you guys a second to take a look at this and see if you can figure out between A and B with the velocity, we're just saying, is it positive, negative, or 0? And acceleration, am I speeding up or slowing down? So you might need to go to page 1 if you want and take a look at those. So again, in order to find out if I'm speeding up or slowing down, I need to take a look at if my acceleration is positive or negative. And remember, if the signs are the same, I need to compare my velocity with my acceleration. If the signs are the same, then I'm speeding up. And if the signs are different, right, then I'm slowing down. But I'll let you go back and take a look at that, and we'll come back to this.